Okay, ladies and gentlemen, we are going to discuss inverses of trig functions today. So we need to remember what an inverse is. Okay, so way back in the beginning of the course, we learned that an inverse was when we switch the x and the y. Okay, but, that's a very simplistic explanation. But there was no guarantee that when we did that, that our inverse would also be a function. Now remember, a function has a one output for every input. Okay. Now, for an inverse, to also be a function, the original function must be 1-to-1. Okay. Now, being 1-to-1 means that not only for every input do you only have one output, it means that for every input you have a unique output. Okay, so how we found that out is we use something called the horizontal line test. Now, let's take a look at the graph and function of sine of x. All right, so let's really quickly graph that. Okay. Ah, okay. Okay, so what's going to happen is we're going to graph, okay, sine, and we're going to see that it doesn't pass that horizontal line test. And again, this is a really quick graph. Okay, but that's the graph of sine. And we can see that that graph fails a horizontal line test because it's periodic. So in order to ensure that whatever inverse I come up with is an actual function in and of itself, what we do is we restrict the function to force it to be 1-to-1. So kind of the easiest place to restrict it is going to be right in the middle. So we're going to make our graph of sine just be this orange bit right here. Okay, so our new domain or restricted domain becomes negative pi over 2 to positive pi over 2. And then our new range is negative 1 to 1. Okay, so if I restrict that, I can find an inverse function. Now, so when we find the inverse function, we switch the x and the y. And so when we do that, we wind up with a graph that looks like this. So this becomes pi over 2. This is 1, and this is negative 1. So my graph looks like this. Okay. All right, so we're going to do the same thing with cosine and tangent. So we'll do those a little bit quicker. So let's write a little reminder here. Remember, when we find an inverse, the domain and range switch places. Okay. All right, so the domain of our inverse function is going to be and our new range okay, so let's talk about cosine now. And again, if you look at a graph of cosine, you will notice that it is not 1 to 1. Okay. So, and again, just a really quick graph. So what happens with cosine is we restrict our domain, okay, to this bit right here. Okay. So our restricted domain our range. Okay, so when I switch it and I do the inverse, okay, remember our X and Y switches. So it looks like this. Okay, so our domain is now -1 to 1, and our range is 0 to pi. Okay, again, we restrict. Okay, let's talk about tangent really quick, and then we'll get into how to use these in the next video. So tangent, remember, is the one with the asymptotes. Again, we're just trying to restrict our function so we do have that go ahead and graph. Okay, so you got to remember that nothing has really changed with these. We're still switching our X and our Y, but we're actually having to do a domain restriction. Okay, so let's put in some asymptotes. So here's our tangent graph. Like that. So it makes sense to kind of just take the middle tangent curve. So that's how we're going to graph it. Okay, so again, now instead of vertical asymptotes, we have horizontal asymptotes. And we get something that looks like this. All right, so let's talk about our restricted domains with this one. Okay, so your restricted domain for tangent is going to be -pi/2 to pi/2. Now notice I put parentheses around that because the pi/2 and the -pi/2 are not necessarily included. Okay, I shouldn't actually say that they are not included. Oops. Okay, so because there are asymptotes there, okay, so they're not included in your domain. So your range is actually -infinity to +infinity because our tangent doesn't have a max or a min. Okay, so when we talk about the inverse, our domain becomes negative infinity to positive infinity, and our range is negative pi over 2 to positive pi over 2, because that's where those asymptotes are now. Okay, so in our next video, what we'll do is we'll get into how to use these graphs. Okay.